This podcast is really part one of kind of a two-podcast series that talks about the development of the atomic theory. And we have to go back a long ways to the first guy we're going to talk about. He wasn't really a scientist, but he was a Greek, and his name was Democritus. And kind of just going along with all the Greek stuff, kind of looking at the world and trying to make sense of the world. Democritus may have been the first scientist. Usually the Greeks kind of reason stuff out, and they're very philosophical. But Democritus kind of looked at the world and said, hey, let's see if we can figure out what this thing's made up of. So he basically said the world's made up of two different things. The first thing is what he called atomos. All right, we're just going to spell this A-T-O-M-O-S. Atomos. And these were just tiny, indivisible particles. So again, tiny, indivisible, or just unbreakable, indivisible particles, or pieces, really. And again, he called this atomos. And he said the second thing that the world's made up of, it's either atomos or it's just empty space. So it's not taken up by anything, just emptiness. So again, he boiled everything down to empty space. Another Greek guy that lived really a few years after him, maybe 100 years or so, was Aristotle. And he said, no, it's not made of these things, but it's made of earth, wind, fire, and one other thing. Doesn't matter what that thing is, but the band Earth, Wind, and Fire, Earth, Wind, Fire, and Water. There we go. So he said it was made of those things, and basically because he was such a good arguer, basically mankind thought he was correct until the Middle Ages. All right. So again, Democritus said, hey, let's go tiny indivisible particles and empty space. But because he wasn't that great an arguer, philosophical debater, kind of Aristotle won out, and Aristotle was believed. So the other guy we're going to look at is Dalton. All right. And Dalton lived around 1807. So again, think 1800s, early 1800s. For Democritus, we're going to say about negative 400 BC-ish. So a long time, way long time ago. So about 2,000 years later, Dalton, another scientist, kind of sets out to say, hey, let's start defining what this is that we have. So Dalton, I believe he started looking really at gases, but again, trying to figure out what chemistry was. Really throughout the Middle Ages, most of chemistry was simply alchemist. They were trying to take things that weren't worth much and change them into things that were worth much. So they're trying to take iron and change it into gold, or stuff that didn't matter to make it expensive. So really there were a lot of charlatans and just people that were out to make a buck, but really had no idea what they were doing. So again, Dalton tried to come up with ways to explain what he was seeing and really try to make sense of stuff. So he was really one of the first chemists. And he basically came up with the 5 tenets. Alright? And tenets are just proofs or ideas, rules about what matter was. Okay? So we're just going to label these 1, 2, 3, 4, 5, and then kind of talk about which ones are still true, which ones aren't true, and that's where we'll leave it for today. Alright, so the first thing he said was elements are made of tiny particles called atoms. This seems strangely familiar. Elements are made of tiny particles called atoms. And really, he kind of stumbled across Democritus' work from 2,000 years ago. Okay, so he called them atoms, just kind of as a shout out to Democritus for his calling them atomos. Alright? So again, that's where the word atom came from. So again, first thing, elements are made of tiny particles called atoms. The second thing is that all atoms of a given element so again, all atoms of a given element are identical. So if you were to find an atom of gold and I were to find an atom of gold, we compared them, they would be identical in every way. Again, kind of where we're headed, they're going to have the same number of protons, same number of electrons, same number of neutrons, their size is going to be the same, all the properties are going to be identical. Okay, so that was the second thing. Elements are made of tiny particles called atoms, and all atoms of a given element are identical to pretty much every other atom of that element. Next thing is the atoms of one element atoms of one element are different from atoms of another element. So whenever we're looking at all gold atoms are identical, that's number 2. But if we were to compare gold atoms to silver atoms, they would be different from another. Alright, which is why gold has different properties than silver, or gold has different properties than copper, or cobalt, or zinc, or iron, or sodium, whatever it is. Okay? So again, third thing, the atoms of one element are different from the atoms of another element. The next thing is the atoms of one element can combine with another to form compounds. Let's say the atoms of different elements can combine. I don't know what I was going to spell there. Can combine to form compounds. We've talked about compounds before. Again, he was kind of just the first guy to try to define and put to words what he found to be true in nature as he kind of experimented with stuff. And then the last thing is atoms are indivisible. All right, and again, that's kind of just a shout out back to Democritus. Atoms are indivisible. Okay, so a couple things, and I just want you to definitely have this in your notes. We're going to find out in the next day or so that number 2 is false. Okay, number 2 is not true. All atoms of a given element are not identical, but there's something different about them. I'm not going to tell you right now. I'm going to save this. Make you wait in suspense. And then the last one is number 5 is sort of true, sort of false. The atoms are indivisible, and you might just add that is true if it's a chemical process. Are indivisible in chemical processes. But we're going to find out this unit is in nuclear processes. We can actually break an atom apart. Alright, so in chemical processes, and what we're going to find out is with nuclear energy, we can divide atoms, and there's a little bit of mass loss, and that mass turns into huge amounts of energy. Alright, so number 2 is always false. Number 5 is true if we say chemical processes. If we don't give that caveat, then it's false as well. And that's what you need to know about Democritus and Dalton.